So let's walk through this code, clear everything out, load in our packages. So I'm working from, or I started from this link here, which, oh, there we go. Let me pull this window across. Doesn't work if you just put it in quotes. There we go. So, one thing that has been giving me problems is I'm basically extracting the URLs from all of this. Actually, I think from this results column. Right? So I've got rvest basically pulling the links out of this page that include Ergebnisse. I don't know how to pronounce that. The win-loss results. For some of them, it's giving some problems, and I think it has to do with the webcasts. Maybe. I don't know. Oh, you know what? It might be this, if this has an image in this table. So, well, let's take a look at a feature of this particular website. This is like old school web design. Everything's in a table. It's a table in a table. So let's see, there's the body. There's a table. Table body. Table row. Another table row. There we go. There's tables in there. There's a table over there. Somewhere in here we got another table. Right? There's just tables and tables and tables. There's a table. This table is going to turn out to have some results that are interesting to us. We're going to pull out that date venue announcers. So there's all kinds of stuff in here. And really the magic is pulling out the right tables, which just involves a little bit of poking around. So this is the URLs, or sorry, the page with the list of URLs. I read that as a page into rvest with read_html. And then I pulled out the 15th table, which I found after doing some poking around. Look at matches underscore table. I'm getting this big convoluted mess. Here, legend, C indicates card, R indicates results. That is basically saying these two columns. Let's see, is there anything here that is useful? I'm gonna have to scroll way up. Oh, here we go. So now we're seeing dates and titles. So matches table, basically I've gotten this table down here with the links to the matches. Then I pull out all the links from, not from the table, from the page. I guess I'm not using the table. Oh, look, I left myself a comment. Not sure if I'll actually need this. Let's just clear it out and see if that doesn't break everything. Matches keep. So here I am pulling out of the links the ones that have their results. And then the pages to keep I am taking out of all of the links. So let's look at this. If I look at matches underscore links, getting this big mess of links, and I don't want a lot of them. Right? I don't want the privacy page. I should look at the legal page if I'm going to do anything with this, but for now it's just educational. All right, so matches to keep. I'm keeping the links that have the results, right? I don't need the card. I don't need the default page. All three of these go to the same page, but I want to go to the version of the page that highlights the results. So, for example, if I look at this Monday's raw results, if I go to the page, I'm getting just the show. I could go to the card. Ooh, this actually might be interesting because this is giving sometimes named matches. Symphony of Destruction match. But in any case, what I've got set up so far goes to the results. Oh, okay. In any case, so this now puts the names in orders of who won. All right, all of this to say, let's see, I've gotten down to matches keep. I go to pages to get, which is where I take out of all of the matches links, out of all this mess. I subset to the ones that I want to keep, which is out of matches links. Where do we see this word, which I assume is German for results? All right, so I'm keeping these. I'm taking this and getting the subset of the ones that meet this condition. Right? So I'm taking those links. Let's just run that to see what it looks like. I'm getting these links, and then I'm pasting on the start of the URL so that I can plug those into my function and download the page, right? So this relative link, it's not going to work unless I tell RVest we're getting that page from this website. All right, now this is, so all of this that I just did is my way of getting from that list of shows, this list of shows, and trying to pull out all the results. Now I'm going to run into some problems here, which is where you come in, but here's what we've got. Right, so I've taken that page with a bunch of links, and I've restricted it down to the links that I want. Now, I might not want all of those links. I might, for example, want to, let's see, I'm not going to get it out of the links, but I might say use this table. I could possibly, maybe, I don't know, maybe I take this table and that allows me to say exclude the webcasts. I don't know. This all takes, experimentation, and you tweak things and it breaks and you go back and you fix it. And this is why you want to do this stuff earlier rather than later. Fortunately, it's all a logic puzzle, so it's at least kind of fun. All right, so I'm going to set as URL, just so I can test out this functionality in this function. I'm going to say the URL is pages to get 1. So there's my URL. I'm going to be looking at this particular result, 493588, which is raw number 1436. It was this Monday's result. So this is the page I'm extracting information from. All right, show number. I take that URL and I pull out the show number, right? So you can see in the URL here, I've got show equals 493588, and I've extracted that from this string, from this bit of text. I pulled out where do I have numbers. So this is a little bit of regular expressions, and regular expressions are nice because they allow us to look for patterns in text. In this case, it's a really simple pattern. There's only one place in this URL with numbers, and it's exactly what I want. So square brackets 0 to 9 means I'm looking for something from 0 to 9. Right? I'm looking for numbers, 0, 1, 2, 3, and so on, and I want one or more of them. Right? So that gets me everything. Let me just show you really quickly some alternatives. Well, not alternatives, something that's not going to work. So if I just say 0 to 9, it just gives me the first number. If I say 0 to 9 and then the asterisk wildcard, that means 0 or more, and so it gives me 0. Let's see if I can remember these guys right. Let's say if I'm going for between 1 and 3, it gives me 3. 1 to 4 gives me 4. If I say 2 to 4, it's still giving me 4. If I just say 2. If I say 2, it gives me the first 2. So this is asking for a specific amount in the curly braces. It's been a while since I've done any regex, but I guess this should be a range. This should say if there is something, let's say if there's something from like 4 to 8. So in this case, there's only 6, which is in this interval. So it gives me the biggest chunk that it can out of that interval. But the plus sign, this turns out to work well enough for us. All right, so we got the show number. So this is now stuff that we're trying to do within extract page. All right, so we take those tables. Now tables, we're reading the URL, so we're getting that page, and we're putting it into this big, nasty table. Or actually, fortunately, it's a list of tables, and some of those tables are a real mess. So let's see, what do we get from tables? The first element, we're getting this site uses cookies. And so at this point, basically what I did is I just worked through them. So I just tried them one after another. Table 2, we're getting 95 observations of 165 variables. Let's just pipe that into Tibble to make it a little easier. 95 observations, 165 variables. Right? So here we are looking at table 2. Oh, I see. Right. I'm reading this right now. Let's see. Is it glimpse? There we go. That's a little tough to read because there's so much stuff packed into here. But basically what's going on with tables is, since this page is in tables, we got a table here, we got a table within a table, we got this table within the table. We want to find the right table. And Arvest has very fortunately pulled all of those tables into these separate elements, and some of them, fortunately, are going to be the ones that we're after. All right, so we got all the tables. I'm calling this R1. That's just a temporary thing. This is the 24th table. Tables, oops, 24. All right, so this is basically the results table. This is this table at the bottom. So by poking around, I think this is the last one. Well, this is the last one. I don't know if that's a common feature. So it's possible that you could improve this by, say, replace 24 with something like length of tables, right? So tables is a list of 24. The length of tables is 24. So if you replace this with length of tables, it'll be 24 for this page. But we'll see in a little bit that sometimes we get some bad results, some results that don't work. But let's keep chugging through this code. So we pulled down those tables. Average age is this last row of this table. So that's information. Let's try and pull that information out. So we take this table, R1, and we take the last row, and then, oh, this is nice. Read our parse number is going to pull out this 36.8 for us. We don't even have to do the regular expressions here. Let's see what that looks like. We take R1, we take the last row, and we parse out the number. And note also, we pulled just the second column. Right, so here I showed you the whole thing, but really R1 is just that second column. So we pull out that last row from that one column table. Let's just make sure. Dimensions. All right, so I think this is being treated as a vector, but tail1 is giving us the last element of that vector. So R1, we get that tail, and then from there, read R, which I think actually we might not even need to specify. There we go, right? So we don't really need to specify that that's from the read R library, but it doesn't hurt to. So we got average age. Our average age for this show, 36.8. All right, R2, what are we doing? We're dropping the last row from R1. So R2, we've got the results, but we dropped that average age. So the format on this website is we got that last row, but really we want this section of the table. We don't care about 1, 2, 3, 4, 5, 6, 7. We care about this column. So that's what we got. We got that second column, and we picked up this for free in R1. So we pulled that out, and now with R2, we're restricting ourselves to this second column, but not this last row. So there's R2. So I'm just kind of working through piece by piece. I don't actually need R2. I could hypothetically pull this together in a longer chain, but this just kind of worked well enough for me. All right, R3, what have I got there? So I'm taking R2, I'm column binding that to something. So let's see what that something is that I'm getting. So I'm taking R2 value. Right? R2 value is this. Right? This variable from this. And I'm looking for string split fixed. And what I'm doing with this is I'm taking that vector and I'm splitting it on defeated. So this is going to be a little bit of extra cleaning that I haven't sorted out. But what I'm going to get is this separated from this. I'm going to have this on the left, I'm going to have this on the right. So as long as I've got defeated everywhere, this bit of code works. It splits this one element into two, which is what we've got here. Symphony Destruction Match, Jeff Hardy defeated Elias. All right, that was R3. Now let's see what we're getting with R4. We're doing the string split on by. So specifically, we're taking that third column that we get in R3, and in this case, we see The Miz and John Morrison were defeated by disqualification. Right? So not everyone's defeated by disqualification. It'd be nice if it said something like defeated by getting bashed in the head with a chair, but we've at least got disqualifications. All right, so R4, we bind that to R3, and then I'm renaming the columns in R4 to make life a little bit easier. So here's what R4 looks like. I've got the raw text that I started with, right? And that, again, whoops, is this chunk of the table. Whoops, where'd I go? This chunk of the table. Oh, that's cool. So I could be pulling out links on the wrestlers also. But that's another problem for another day. Let's keep working through what we got. So I've got that raw text, and then all of this stuff up here is just processing it down to this level. So I know the winner is the person to the left of defeated. The loser is the person to the right of defeated. And in some cases, I've got by disqualification. So The Miz and John Morrison lost by disqualification. All right, so I've got that. I've done a lot of the processing, but there is still Symphony of Destruction match. I guess you could look for where do we see match under the winner column, right? So we don't need to solve this in this particular, what am I looking for? In this particular function, right? We could fix this somewhere else. Holy crap, it's already been 19 minutes. All right, let me wrap this up. All right, so our match results. We take R4, we set it up as a tibble so that it's not printing over all this stuff, over all these lines. All right, we're getting something like this. We're trimming the white space from all the text. So now we're getting just the text. We're not getting these blank spaces. That also conveniently changes this to treating it as characters, as text, rather than as factors. That's going to make it easier to merge later. And then we're going to select just the columns that we're most interested in. We get the winner, we get the loser, how they won, if we have that, and then we got the raw text just to be safe. So that is the match results. Okay, so what have we done? We've done about 50 lines of text, or 50 lines of code. Some of it's set up, some of it just pulling out a list of URLs that we're interested in. But we've got code that for some page will give us some result that looks like this. We also got the average age, right? So we want to throw that in. And then the other part we're going to want to pull out is this bit, the date, the venue, and then we also want that show number that we pulled out at the start of this function. All right, so the match details. Tables 13. So we pulled all the tables, and it happens to be that the 13th table gives us the information we want. Now you see it's repeating 3 times. That just has to do with the structure of this table. So we've got 4 columns, but we've got some columns that are spanning, or some cells spanning multiple columns. So general information is going to repeat 4 times at the top of each of these. I don't care about the phrase general information. I don't care about previous event, right? I don't care about show archive, WWE. I really just want these 3 rows. So I slice out the first row and the nth row, right? So here I'm saying n, that's going to tell me how many rows have I got in this, and I'm going to cut that out of what I've got. So when I do this, I'm getting all the rows for columns 1 to 2, and then I'm explicitly slicing off the first row and the last row. When I run that, what do I get? I get x1, x2. I've got the key information that I want. So there is the key details in a table, which isn't necessarily the most efficient way to get it, but this is the way I solved it yesterday. All right, so I take that table and I pull x2. That's going to give me just the second column. And at this point, my code gets a little hard to understand. If I'm honest, I'm kind of making a lot of items within this function, but fortunately at the back end, this is all kind of encapsulated within the function. So once we are running the function, it's really not going to be too bad. All right, match details. We got the table. Match meta. We've got specifically the details that we want out of there. I wonder, I'm going to actually just put that like that. And then, I wonder if I can do this. Can I replace match meta with match details? So match meta, I've got that. Let me try it like this. Match details. Looks like, oh, match details table. I'm going to call this match meta. Let's leave those as match meta. Change this to match meta. All right, so there's match meta. Okay. This is just one less variable to deal with. So that match details table, I don't really need. Match meta, I don't really need, but it's going to get eliminated outside of the function anyways. All right, so I've got the details I want, and then I roll them together as a tibble. So match underscore details. I've got the show number, right? Show equals show number, average age equals average age, date equals match meta element 1, match meta element 2 is the place, and the announcers are the third element in that vector we just created here. And then we are going to c-bind that to match results. And I was looking at the possibility of nesting this, which, well, let's take a look at what that looks like. So when I nest that, I get just the key details and then the data about the matches, which all share the same details as the show. They all happened on the same date. They all had the same announcers. So here, I've just compressed that, right? I've nested it, so I've got a tibble within this larger tibble if I do the nest. But I'm going to not nest it. That's going to make it a little bit easier further down the line. And actually, let me just eliminate that code. Let me eliminate this code also. An earlier version of this, I was returning this chunk to the left and then this chunk separately as two elements in a list. But this way, it's all in a data frame that we're going to be able to roll together. All right, so there is the function overall. So let's extract. Let's see, yeah. We'll go extract underscore page for our URL. And let's see what we get. Cool. We did what we wanted. So for that URL, we've got something that automatically pulls out what we want. You know what I do want? I want this just to be formatted as a tibble. I'm going to run that goes, it downloads the page, it does some processing, and it spits out this nice tibble that gives us everything we need. We got the show, we got the age, all this metadata about the match itself, about the, I don't know, the event, and then each of these 7 matches, we've got the details. Now, we do still have some cleaning to do, but hypothetically, we have something that we could put into a call to map that would give us a whole bunch of stuff. So I'm going to let it break here. All right, so we're getting a parsing failure. Column expected a number. Actual was Kurt Stallone defeated Raul Mendoza. And then it breaks, right? So we don't have this item T. We have transpose, but we don't have this temporary thing I was trying to get. So something in extract page, right? We could, basically we need to find a way to identify what's causing these problems, and especially this error that actually breaks it. So let's see what the trace back is showing. And it's not going to give us the specific URL. Let's do this. Let's just add print show number, and let's run this one more time. So now each time it's calling, hopefully, well, it's not going to print. Let's try it again. So there we go. All right, so it's giving us some results. So hopefully it'll tell us what show is breaking this for us. All right, 493412. Is that the one that broke it, or is it 493594? All right, 493414. Let's see what we can find out of that, and then I'm going to upload this video. 494, 493. 493414. You know, I might be able to get it out of this. I don't have that match table. Matches table. Do I still have that? I don't. I accidentally pasted extract somewhere. Introducing typos. Matches page. All right, I don't need extract there. Okay. So, matches table. Oh, and what do I want want to do? I want to filter that down. But am I going to be able to pull this out? Yeah, so this is giving me titles, but not links. In any case, we know where it breaks, or where it breaks first. We just don't know the link to where that breaks first. What is it? 1, 2, 3, 4, 5, 6. Should be 6 rows down. 1, 2, 3, 4, 5, 6. The main event. 4. Okay, here we go. 493414. Okay. This is where. Okay, so this is a rerun. So what we might look for is. Oh, okay, yeah. So what you can look for here is basically add in a little bit of functionality in extract page that will look at this results table. All right, so I guess R1. If you look in R1, look for reruns, and this is going to be something like R1 string detect. We're going to detect that out of, well, I guess out of R1. We still have R1 saved. Look at R1. Where's R1? R1 is that. Tables 2. Date. Oh, I'm pulling this. All right. So we got results. All right, so it's not exactly out of this one, but here's what we should do. So we'll call this first break equals just the text of this URL. And then with that, I've got what I need, I think, to try and figure this out. But basically what you're going to try and do is try to make a function that detects something that shows something like matches from the following shows were aired to try and catch those reruns. So here we've got the results card, but really we're running into problems because of this rerun. So that's the puzzle, right? How do you find that? So find rerun for a URL, right? You basically just need to fill in that block to make that work. All right, I'm going to upload this now, and I'm going to get ready for my day. So I hope that was helpful, Dan. Good luck.